let's continue from here. Welcome back. And what we see is the following. We had f of x is equal to x over 2, and the first derivative of fx is equal to minus 2 over x squared. Now, if the question is determine the value of f dash 4, that is very easy. So the function that we're going to use now is this one over here. So instead of an x over there, we can just substitute it over there, and then we have a minus 2 divided by 4 squared over there. Okay, instead of the x we have the 4, and that is very easy. You can either do it manually or in your mind, or you can just use your calculator and you'll get to the answer of minus 2 over 16, and that is equals to minus 1 over 8. So that is the value. Now, what does this minus 1 over 8 mean in the scenario that we have here? Remember, your first derivative of a function is actually the gradient of that function that you're working with. Now, in this case, we have a hyperbola. So let's quickly draw that one. Let's do it this way, a quick one. We will see it, the hyperbola is 2 over x, so it will look something like this over here. Sorry, it's positive. There we go. So this is more or less how this hyperbola might look like. Now, what happens here is the following. They say what determine f dash 4, and we saw that the answer is minus 1 over 8. So say for instance 4 is over here, so that point is a very special point that we can look at. Actually, this is the gradient of this hyperbola exactly at that point over there. Now, to see that clearly, what we can do is we can draw a tangent at that point. A tangent at that point. So the gradient of this tangent is actually the gradient at that point of this hyperbola. So that is what this minus 1 over 8 represents. And that is that the gradient of this tangent over here is equal to minus 1 over 8. And that's how we're going to determine that. Now, the following question would be now, what is the equation of this tangent? That is normally the next question that will be asked. Okay, let's quickly have a look at that and see how we're going to determine that. So, first of all, y minus y1 is equal to mx minus x1. That is my standard formula to determine the straight line. We do have m now in this line over here, because we already determined the gradient of this line. So all that we need to do now is to find another point, find another coordinate that we can substitute the x and the y in there. Well, actually, we do have, already we have a 4. We have the 4 over here. We can substitute that with 4. So what we need to determine now is the y value. And remember, the y value over here is the y value of this hyperbola that we can determine. So let's determine this y value of the hyperbola. And that will be the value that we're going to substitute in y1. Okay, so that is very easy. So we use our hyperbola, our original fx. So we can say f of the value for 4 is equal to, and remember this is the fx that we're going to use, it's 2 over x. So it is, let's write down 2 over x is equal to 2 over 4, and that is equal to a half. So the coordinate of this point over here that we're going to use is 4 and a half. So we're going to take this half and we're going to substitute it in y's place, and then we have our formula for our straight line. So let's continue. We have y minus a half is equal to m. We already have the m. is minus an 8 times, and we have the x minus the 4 over there. Right, okay, we have fractions over here. That's a little bit difficult to work with. So to get rid of the fractions, we're going to multiply by 8. Everything by 8, so we can get rid of our denominator over here. So I'm going to take this whole equation of mine and I'm going to multiply it by 8 so that I can get rid of that 8 over there. 8 times y gives me 8y. 8 times minus a half gives me minus 4 equals to, that will cancel out, I only have a minus there, and in my bracket I have an x minus 4 there. So let's kick this minus 4 over to the right hand side, it becomes positive then. So we have an 8y over here, the minus equals to minus x, so it's positive, and the positive gives me a plus 8. Right, I'm going to end this equation over there, else we're going to have a lot of fractions going on there. Right, thank you for watching and all the best for the rest. Thank you.